Welcome to the second part of our third lesson in Unit 3, Factoring, in our Grade 10 Academic Math class. So we've just learned how to factor tricky trinomials using decomposition. Now we're going to work through 6 examples as just a way of practicing before we get to our homework. As I said in the first part, this is challenging, so be patient with yourself. Follow along, maybe rewatch the first video a couple of times just to make sure you kind of understand what's going on, or at least what we're doing, maybe not how necessarily yet, but what we're doing. And let's get to some of these examples. So here's our first one. We have 3x squared plus 5x plus 2. So I want to really try to model here good factoring behavior. And the first thing I'll do anytime I look at a question where I'm being asked to factor is there a common factor in these 3 terms that I could factor out front? And there isn't in this case. So I recognize that this is still a tricky trinomial because the coefficient out front of the squared term is a 3 and not a 1. So I want to find the 2 integers that multiply to, and I'm going to write this out just a few more times, a and c. Now a and c represent the coefficient out in front of the quadratic term and the constant term. So what I want to find is the thing that multiplies to plus 6, but that adds to plus 5. And that plus 5, that's our b value hanging out in the middle right there. So there's our plus 5. Let's get the colors going on here. There's my a and my c value leading us to plus 6. So I'm going to find 2 values, or 2 integers that multiply to plus 6 and add to plus 5. So as I think about the factors of plus 6, I realize that those 2 values are going to be plus 3 and plus 2. And now I'm going to decompose this middle term of my quadratic down to plus 3x and plus 2x. So I'm decomposing that middle plus 5 into these 2 values I determined over here, and then I'm just going to recopy the first term and the last term. Now something that people ask all the time is, does the order that I write these terms in matter? So for example, could you have written plus 2x plus 3x? Absolutely, that's not a problem. Your answer will work a different way, but you'll arrive at the same answer. So absolutely, you can feel free to write those 2 integer values in any order that you want. So now, as before, we are going to be common factoring the first 2 terms while ignoring the second 2 terms. So we're going to ignore this guy over here. So what is the greatest factor common to 3x squared plus 3x? We see that the greatest common factor is 3x. And when we factor 3x out of the first term, we're left with an x. And when we factor 3x out of the second term, we're left with a plus 1. So now we're going to unignore the last 2 terms, and we are going to ignore those first 2 terms to common factor the last 2. So what's the greatest factor common to 2x and plus 2? It's going to be plus 2. And that's going to leave us with, in our brackets, x plus 1 once we factor it out. So we're looking good so far. Now we have 2 terms left. One big term here, 3x times x plus 1 in brackets, and plus 2 x plus 1 in brackets. So we have these 2 terms. What's the greatest factor common to both of them? It happens to be this binomial, and you're going to find that happening a lot when you are factoring using decomposition. This binomial will, again, if you've done it correctly, will always be the same. So that is our greatest common factor. We are going to write our greatest common factor out front, and when we factor x plus 1 out of our first term, we're left with a 3x, and when we factor x plus 1 out of our second term, we're left with a plus 2. And that is factoring using decomposition for tricky trinomials. Let's bump over to example B. Here we've got 5a squared plus 14a minus 3. Is there a common factor that we can factor out of these? The answer is no, there isn't. So that means we're going to treat this like a tricky trinomial because there's a 5 out in front of our quadratic term. So I want to find the thing that multiplies to a times c. So there's a plus 5, and and there's c minus 3. So I want to find the thing that multiplies to negative 15, but that adds to plus 14. That is our b value hanging out here on the linear term, or the term with just one a happening in it. Just working on the color piece. There we go. All right. So we want to find the factors that multiply to negative 15 but add to positive 14. So those two numbers will be, and again, if you're struggling with the factoring piece, I'm going to put a link up in Unit 3 to something called a factor sheet, which lists all the numbers from 1 to 100 and all of the sets of factors, so the two number sets that multiply to a particular number. I'm going to put that up there in a link that says factor sheet. So hopefully this will help you if your times tables are not top-notch yet. So the two numbers that are going to work here for us are plus 15 and negative 1. That's the combination of numbers that will multiply to negative 15, but that will add to plus 14. So the first thing I'm going to do is I'm going to decompose my middle term, negative 1a. So there I am. I've decomposed plus 14 down to plus 15a and minus 1a, and I'm just going to recopy the first term in the first spot and the last term in the last spot. So far, so good. Now, as before, I am going to common factor these first two terms, and I'm going to ignore this guy over here. So what is the greatest factor common to 5a squared plus 15a? The answer will be 15 will be 5a. And when I'm done factoring 5a out of my first term, I'm left with 1a. And when I'm done factoring 5a out of 15a, I'll be left with plus 3. Okay, so time to unignore this guy. Now we're going to ignore the first two terms, and we are going to common factor the second two. Now, what's interesting here is that our leading term is negative. So we are going to factor out a negative value here because this is a negative term. So I'm going to factor out the greatest common factor to negative 1a minus 3. It happens to be negative 1. Now when I factor negative 1 out of negative 1a, I'm left with a positive a. And when I factor negative 1 out of negative 3, I'm left with a positive 3. Now this will be a little bit confusing for some students, so let me just explain this piece here in just a little bit more detail. So again, in order to fill these values in, essentially what I'm asking myself is negative 1 times what number gives me negative 1a? And that would be a. And then I would go on to ask myself, negative 1 times what number will lead me to negative 3? And the answer would be positive 3. So if you're struggling with the idea of factoring out a negative number, maybe try to frame it in that way, and that might help you out a little bit. But here we are. We have two terms left. We have this big term here, 5a times a plus 3 in brackets, and negative 1 times a plus 3 in brackets. What's our greatest common factor? It is the binomial, a plus 3. So when I common factor that out front, what am I left with in my brackets? Well, when I factor this out, 5a remains. And when I factor this out, negative 1 remains. So this is how you factor tricky trinomials by decomposition. We've just done two examples. I guess I was still a little bit slow since we're already at almost 9 minutes. So again, I think I will stop here, and then I will squeeze somehow more quickly the last four together in the next video. So this is the end of part 2. Stay tuned for part 3.